Now we are going to write electric field at a point along equatorial line of a dipole. Equatorial means perpendicular bisector you take. Sir, minus Q plus Q. Exactly at the perpendicular bisector and considering the point C. This distance is 2D. This is R. AB. From the center to the point C is R. As usual, same discussion. Plus Q, direction of electric field is away. Minus Q, direction of electric field is towards. So resultant, this one and this one, resultant we have to calculate. Here, this is theta, this is theta. This point will consider point C, E plus. Sir, this is theta means this angle is also theta. So you have to resolve E plus into two components. Why we have to resolve? What is called resolution? Any system not in equilibrium position, exact horizontal, exact vertical, it is not having. Then it is not in equilibrium position. You have to resolve. E plus is in some other direction. So we have to resolve into two components, E plus cos theta, E minus cos theta. This is E minus direction. Sorry. E plus cos theta, E plus sin theta. E plus only are resolving. Sin and cos. This is E minus direction. This is also theta. You can resolve E minus also into two components. E minus cos theta, E minus sin theta. E plus, what is the value? Q by 4 pi epsilon naught BC square. What is BC square? BO square plus OC square. That is R square plus D square using Pythagoras theorem. E minus I will write there. Right. Q by 4 pi epsilon naught AC square. What is AC square? AO square plus OC square. Same R square plus D square. So E plus value and E minus value magnitude is same. Direction E plus sin theta, E minus sin theta here cancelled because opposite direction cancelled. But cos component you see they are in the same direction. So E equatorial will be E plus cos theta, E minus cos theta, E plus E minus both are same. So I can write 2E plus cos theta. Sir, vectors and I want to put, sir, you put no problem, R cap. Minus sign you have to put then. Why minus sign? From this point towards the left, this is origin, I cap minus I cap. This is y axis represented by j cap, down minus j cap. This is on the left, so minus I cap. Substitute the value of E plus or E minus anything. Find out cos theta. What is cos theta? Adjacent side by hypotenuse. Adjacent side is OB, that is D. Hypotenuse is BC. BC is nothing but BC square is R square plus D square. So BC is what? Root of R square plus D square. Root of R square plus D square. Substitute that value, final answer will be P by 4 pi epsilon naught, of course, into R square plus D square whole power 3 by 2. P by 4 pi epsilon naught R square plus D square whole power 3 by 2. Into R will not come here. As usual, what you have to do? Compared to R, D is very small. So D square term is neglected. D square you neglect, means what is remaining? R square power 3 by 2. R square power 3 by 2 is R cube. So equatorial line, value of electric field is P by 4 pi epsilon naught R cube. You want to get minus sign. Vector means minus sign. Axial line, we saw it is 2p by 4 pi epsilon naught R cube. Whereas equatorial line means it is p by 4 pi epsilon naught R cube. This is electric field of a dipole along equatorial line. Next step. Electric dipole in external electric field. Place the dipole in external electric field. What is happening? You observe that this is uniform electric field. You are placing a dipole minus Q plus Q. This is E. So this dipole, one force will be executing here. F is equal to EQ. E is equal to F by Q, we know. So F is equal to EQ. Another force will be in opposite direction, minus EQ. Sir, this is a dipole. Here one force, here one force. It is not this one equal and opposite. Equal and opposite means it will cancel. Line of action is different. Here one force, here one force. When you apply this force, the body will rotate. So this force will try to rotate the body. That rotating force only we call it as torque. You have to explain here how torque is formed. Simply write torque is equal to force in the perpendicular distance. Torque is force in perpendicular distance is correct. Here you have to explain how torque is formed. When you place a dipole in external electric field, two equal and opposite forces, but the line of action is different, is formed. That will rotate the dipole. That rotating force only we call it as torque. That torque is force into perpendicular distance. Force is EQ. Perpendicular distance ABC, BC. This force into BC or this force into CB. Both are same. This is 2D. We have to calculate sin theta. So BC will be 2D sin theta. Q into 2D already you have learned. What? Electric dipole moment. So I can write PE sin theta. Tau vector is equal to P cross E. So this is vector product of two vectors. Vector product of two vectors. Dipole moment is a vector. Electric field E is a vector. Resultant torque is also a vector. Next question. Electric dipole moment minus Q to plus Q direction. Electric field away from positive towards negative, you know. What is the direction of torque? Corkscrew rule. Right hand thumb rule you have learned. You have a plane. In this plane, R and F, force and displacement. In this plane, dipole moment and electric field. Then torque will be perpendicular to the plane, either this side or this side. The corkscrew rule, you told something. Rotate the screw clockwise. Keep it on a wooden piece. When you rotate, the screw will go in. The direction of rotation is clockwise. Direction of the resultant force will be perpendicular to that plane. Similarly, the direction of torque will be perpendicular to the plane containing P and E. You release the screw, screw will come up. So you see the rotation, anti-clockwise, upwards, clockwise. Screw is going downwards, downwards. Thumb rule, upwards, you see here, anti-clockwise. Downwards, you see, clockwise. You can try. This is torque in an external electric field. Electric potential. Potential means work done. Work done in moving. The word work done means it is a scalar. Sir, I have a charge Q. This is electric field. I have a charge Q naught. The work done in moving a unit charge. Sir, Q naught I am moving, sir. You move unit charge plus 1 coulomb. From infinity. Why you are telling infinity? It is outside the electric field. Any charged body outside the electric field when you are moving, that point is called infinity. That's all. Simple. That only 5 centimeters we are having. Don't talk about the number. It is the region of outside the electric field. That's all. It is infinity. Work done in moving a unit charge from the point, that is from infinity to any point inside the electric field, is called electric potential. Sir, I want to calculate the electric potential difference between these 2 points. 2 definitions you can use. 1 coulomb of charge, infinity to A you move, infinity to B you move, difference between W1, difference W2. This is called electric potential difference. Move plus 1 coulomb of charge. From infinity to A, infinity to B, difference between these 2 will give you electric potential difference. Another method, from B plus 1 coulomb, you are moving from B to the point A. Previously, I got 80 joules minus 60 joules, sir. W1 is 80, W2 is 60, 80 minus 60, I got 20 joules. Now, B to A, if I move 20 minus 0, there are also 20 joules. Work done in moving a unit charge from one point to the other, you call it as electric potential difference. Okay. Now, electric potential difference due to a point charge or electric potential at a point due to a point charge. It is nothing but the work done. Force into distance. One charge is Q, another charge is plus 1 coulomb you are moving. So repulsive force minus integrate W is equal to minus integral force is Q into 1 by 4 pi epsilon naught R square dr. No sir, x square only I will put. You put x square, no problem. Then it will become dx, it will become x. From where to where you are moving? Infinity to that particular point. Point B, point A, point B. Here you have plus Q. Plus 1 coulomb from B to A I am moving. Dx. This is R. From the center, this distance is x. So, you integrate the equation up to the point B, you have to move, that is your aim. Move B to A, then A the next point, A the next point, A next. Like that small distance you move. Finally, you have to come to the point B. What distance? R. So, the limit is infinity to R. Q by 4 pi epsilon naught, take it out. This is nothing but electric potential work done in moving a charge. That is called electric potential. Rearrange, your answer will be Q by 4 pi epsilon naught R. Q by 4 pi epsilon naught R square means electric field. Q naught by 4 pi epsilon naught R square means force. This is Q by 4 pi epsilon naught R. Correct. So this is electric potential at a point due to a point charge. Simple. Sir, I want to calculate electric potential at a point due to a dipole. Due to a dipole, I want to calculate. It's a big question. Full derivation we are not going to do. We are going to see the basics. Minus Q plus Q separated by a distance to B. This is AB, center is O. Our aim is to calculate at a point here, say C. Don't put the point C at the perpendicular bisector. It is a wrong diagram. Why, sir? I will explain at the end of the derivation. So put slightly on the other side. Take this as theta. If we say this is theta, this angle should be 180 minus theta. Take this distance OC as R, BC as R1, AC as R2. Now potential due to plus Q charge I want to calculate. V plus, what is the formula? Just now we have derived. Q by 4 pi epsilon naught R. In our case, R1. V minus you calculate. Minus Q by 4 pi epsilon naught R2. Why you are putting minus sign, sir? It is a scalar. Potential is nothing but work done. That work done is a scalar quantity. Scalar quantity means for plus Q you have to take plus Q, for minus, because there is no direction. Okay, so resultant electric field VR is equal to these two you add. Q by 4 pi epsilon naught is common. Take it out. 1 by R1 minus 1 by R2. This is electric potential due to dipole in terms of R1 and R2. There R1 and R2 are two different distances. I want a common term for R1 and R2. Common term means express R1 and R2 in terms of R and theta. Use your cosine law, binomial expansion. Calculate this 1 by R1 and 1 by R2 from this triangle of vector or triangle of addition. Final formula, binomial expansion. Rearrange. You will get the final answer. B is equal to P cos theta by 4 pi epsilon naught. P is called electric dipole moment. P is nothing but Q into 2D. So this is the final formula for potential experienced by a dipole. P cos theta by 4 pi epsilon naught R square. Now theta you put 0. That means minus Q plus Q along the same point line. You have the point C, theta 0. Then potential is maximum. Cos 0 is 1, P by 4 pi epsilon naught R square. No, sir. It is on the other side here. I can put theta is equal to minus 180. Cos 180 will become minus 1. So the answer will be minus P by 4 pi epsilon naught R square. In between these two, theta is equal to 90. When you put theta is equal to 90, the point C will be exactly at the perpendicular bisector. Theta 90 means cos 90 0, potential is 0. That's what I told you while teaching the basic concepts. Don't draw the diagram such that a point C is exactly at the perpendicular bisector. If you draw the diagram, that is wrong. Because theta 90 means the value of V is 0. You cannot explain further. Correct? So this is electric potential at a point due to a dipole. Next. Electric potential energy. That means when you place a dipole in an electric field. There exists a work done. Minus Q plus Q. Of course, torque you have calculated. What is the electric potential energy of a dipole? That is force into perpendicular distance means normal work done. The body is rotating now. So it is torque into perpendicular distance. It is not the force. It is torque into perpendicular distance. What is the formula? Torque into perpendicular distance. Force into perpendicular distance is torque. Torque into perpendicular distance is tau into perpendicular distance. dr. This is called work done. What is torque? P sin theta. Distance you will put dr if it is normal. This is rotation, so I can put d theta. So dw is equal to Pe sin theta d theta. I want work done or energy. Integrate minus Pe cos theta. Electric potential energy of a dipole. Electric potential energy of a point charge I want, sir. Where you wrote Q by 4 pi epsilon naught R for a potential. It is work done. What is electric potential energy of a point charge, sir? Sir, Q1 by 4 pi epsilon naught R is a potential. If you move unit positive charge from infinity to any point, you are moving Q2 charge from infinity to any point, not unit positive charge. Q by 4 pi epsilon naught R into 1 unit positive charge. This is Q1 by 4 pi epsilon naught R into Q2. So the electric potential energy U is equal to Q1 Q2 by 4 pi epsilon naught R. Simple, all small topics. R square means force. R means electric potential energy. Electric potential of a dipole means minus Pe cos theta. Basics only you have to understand. You can write any derivation. Okay. So this is the first part of electrostatics, where we have discussed about types of charges, Coulomb's inverse square law, what is called electric field, properties of electric charge and electric field of lines of force. Then electric field along axial line, equatorial line, what is called electric potential due to a charge, point charge and dipole. Everything we have discussed. This is part 1. Second part we will discuss electrostatic induction phenomena. What is called electric flux and Gauss theorem. Then principle of a capacitor, how capacitor in series and parallel functions. That will come in electrostatics part 2. Thank you. We will continue.